For this video, I picked out an exam question that combines exponentials with differentiation. It's a bit of a different style of question. So it tells you, for the first part of the question, write down the number of plants when the population was first recorded. So that keyword here is first. So I'm just going to change from a highlighter to a pen. All right. So when it's first recorded is when t is essentially equal to 0. So if you put t equals 0 into this equation, that's why it's a 1-mark question. We get that it's 50 times e to the power of 0. Anything to the power of 0 is 1, so that's just 50 times 1, which is just 50. Do bear in mind, it says here the population is measured in, well, it's actually just been cut off, but it's measured in millions, so we say it's 50 million. Let's now move on to the next part of the question. Find the rate of increase in the population 10 weeks after the population was first recorded. So a lot of students make the mistake here of substituting t equals 10 into the equation first and then differentiating. But what you want to do first is differentiate. Now, how you know to differentiate is this keyword here, the rate of increase. Whenever you're interested in how something changes with time, that means you have to differentiate it with respect to time. In this case, we're going to differentiate the population, dp, with respect to time by dt. So how do you differentiate an exponential? Well, there's a little rule I'll just trick you. It's a bit of a trick. If you want to differentiate something in the lines of e to the kx, it's just always going to be equal to ke to the kx. In this case, we're differentiating e to the power of 0.1t, so it will differentiate to 0.1 e to the 0.1t. Of course, in our example, there is a constant before the e to the 0.1t, the 50, so we have to multiply 50 onto whatever we get as the differential. 50 times 0.1 is just 5, so that will be 5e to the 0.1t. We're going to write that here. This here represents the rate of change. In this case, it is the rate of increase because the population is increasing, but it could also be the rate of decrease. Now we can put t equals 10 into it, and we find the rate of increase after 10 weeks. Do remember to do it in that order, otherwise you will end up with the wrong answer. So the t is on the power, 0.1 times 10. That'll become 5e to the power of 1, which I'm just going to put into the calculator. And that's just the value of 13.6. Great. Let's now move on to part C. Find out how many weeks it takes. So here we want to find the value of t, because remember the t is what represents the number of weeks for the number of plants to exceed 300. The first mark here is for forming an inequality, and that's where a lot of students make a mistake. So let's go through how you can form that inequality. I'm actually going to increase the thickness of the pen. It's a bit thin. You take the population, in this case 50e to the 0.1t, and we're interested in where it exceeds, so where it's greater than 300. Let's now rearrange to make t the subject of the formula, remembering to put the greater than throughout the question instead of the equal sign. That's another mistake that students make. You want to start by dividing both sides by 50, so it becomes e to the 0.1t is greater than 300 divided by 50, which is 6. You then want to apply ln to both sides, and I'll show you why that works, just here on the left hand side. If you already know why it works, you can skip ahead like a few seconds. If you apply ln to the left hand side, there's a rule with logarithms that you can bring the power forward as a coefficient, so this can be brought forwards, and it can be written as 0.1t ln e. So that's everything in the power, and then ln e. ln of e is just equal to 1, and that's why it becomes 0.1t. So if we specifically apply ln to both sides, the left hand side will become 0.1t, and the right hand side will become ln of 6. Remember to apply it to both sides, by the way. From there, you can get the value of t by either dividing by 0.1, or you might realize you can just multiply both sides by 10, because then that will give you the value of 1t. So we know it's greater than 10 ln 6, and if you put 10 ln 6 into your calculator, that'll get you a value of 17.9. So we know t is greater than 17.9, and so the smallest value of that t has to be in order for it to exceed 300, because it doesn't make sense to put 17.9 weeks. We'd say 18 weeks. So after 18 weeks, it'll exceed 300. Thanks for watching. I hope this video helped. If you have any tutoring inquiries, be sure to visit my website, www.excellineducation.co.uk. It's on the first link in the description too.